Hi guys, subscribe Education Hub channel and press bell icon to get next video notification.
Hello students, welcome back. Now we are starting new chapter of Science First Standard 10 and this new chapter is periodic classification of the elements. What we'll discuss in this chapter, let's know that. Look at here. At first we'll understood about elements that already we discussed in earlier standard, need of the classification of elements. Then we'll discuss Dobereiner Triad, Newlands law of octaves, Mendel's periodic table and modern periodic table. This chapter is very important from the point of view of your 11 and 12 standard. Okay, so let's begin. In earlier standard we had discussed about matter and classification of matter, particularly according to their chemical constitution, and there we classified matter into three categories: elements, compounds and mixture. So elements, what are mean by element, and in your lesson name also elements word is there. What are elements? In Marathi, very good name for elements is there. In Marathi, elements are called as what? Muladravya. Again I will transfer English meaning of this in different way. Mula means original and dravya means what? Matter. So we can say that elements means original matter. All the substances around us are made to be of some fundamental original matter, and that original matter is nothing but elements. This we can give the raw definition of elements. And same way we are given the definition of elements. Look at here. The substances that cannot be classified into simpler substances, the substances that cannot be classified into simpler substances by any physical or chemical processes are called as elements. ज्यांचं काही अजून सोपं पदार्थात रूपांतरण करता येत नाही ते सगळे एलिमेंट्स दॅट आर fundamental. Another definition also of elements were given: the substances which contain only one types of atoms or molecules made up of one type of atoms are elements. And what are compounds? The substances which contain only one type of molecules, but this molecule should be what? Formed by different types of atom. They are compounds. Now what is classification? What is classification? Classification is nothing but वर्गीकरण, grouping according to certain criteria. काही अटींच्या साहाय्याने grouping करणे. As for example, you, the students in the school, are also classified. Now how you are classified? You are classified according to syllabus you are studying. The students, those are studying syllabus of standard 5, they will be in 5th standard. And the students, that you, those are studying syllabus of standard 10, obviously they will be in what? Standard 10. So this is a classification. Certain criteria, rule is there to classify. Same, elements are also classified and they are arranged into different groups on the basis of what? Similarity in their properties. This is the criteria. Similarity in their properties, and this is nothing but called as what? Classification of elements. But why the scientists feel need to classify element? गरजच का भासली? At first in 18th century, the element known to us were 30 elements. 30 elements आपल्याला माहिती होते. As the science progresses, science develops, the number of elements, new elements have been discovered, and till today, the total number of elements known to us is 118. So huge number of elements are there. And at first, very few elements were there. So the study of elements, their properties, selectively was possible. But when the number of elements increased, such separate study was become difficult, and there was huge number of property of them also. And so scientists start to find out whether there is any similarity, any pattern is present in their properties, and in that way they classify the element according to the pattern in the properties. And so at first we made two groups to classify elements. Basically elements are classified into two groups that you know very well. From 6th-7th standard we know this. Elements were classified into what? Two groups, metals and non-metals. But this classification serves very limited purpose. All the elements that were only two class made by means of this classification, and about metals, huge number of elements are there in a group of metals. म्हणजे एवढं क्लासिफिकेशन पुरेसं नव्हतं, कारण काही मेटल्स तर असे आहेत त्यांच्यामध्ये फक्त मेटल हीच एक प्रॉपर्टी सारखी आहे, बाकी फारच त्यांच्यात वेगवेगळेपण आहे. अँड सो further classification was needed. And again one problem arises here. Some elements show property of both metals and non-metals. You know them. We call them as what? Metalloids. We call them as metalloids. म्हणजे अशा प्रकारचं फक्त ग्रुपिंग करणं पुरेसं नव्हतं आणि म्हणून पुन्हा क्लासिफिकेशनची गरज भासायला लागली. आता हे क्लासिफिकेशन करताना मग आता आपल्याला वेगवेगळ्या शास्त्रज्ञांनी केलेल्या क्लासिफिकेशनचा अभ्यास करायचा. वी हॅव टू डिस्कस क्लासिफिकेशन मेड बाय डिफरंट सायंटिस्ट. दिस टू स्टडी इट easily will make this study in two groups. आपण ह्या दोन शतकांमध्ये डिवाइड करणार आहोत क्लासिफिकेशन मेड बाय द सायंटिस्ट in 19th century and 20th century. In 19th century, look at here, 19th century and 20th century. 19th century begin from 1801 till to 1900, and 20th century become what? 1901 till year 2000. Okay, this is the. आता हा अभ्यास आपण 2 सेंचुरी मधला वेगवेगळा करतोय, म्हणजे तसंच त्या पद्धतीने समजून घेऊ. Now what we know about the element in 19th century? आता जेव्हा एलिमेंटचा अभ्यास करतात तेव्हा त्यांच्या ॲटम्सचाच अभ्यास करतात. ॲटमच्या प्रॉपर्टीज म्हणजेच एलिमेंटच्या प्रॉपर्टी. अकॉर्डिंग टू डाल्टन्स ॲटॉमिक थेअरी, we have studied that all the atoms of the same element are similar. आपल्याला माहिती आहे ते. आणि म्हणून जेव्हा ॲटमचा अभ्यास करतात तो म्हणजे एलिमेंटचा अभ्यास होतो. एलिमेंटचा अभ्यास करायचा म्हणजे ॲटमचा अभ्यास करा. सो व्हॉट इन्फॉर्मेशन नो अबाउट ॲटम ॲट दॅट टाईम? At that time, the total information known about atom was only what? Atomic mass. त्या काही त्याला atomic weight म्हटलं जायचं. Atomic mass was known to us regarding to atom or element. And nowadays what we know that? Atomic number along with atomic mass. So it was obvious that in this 19th century the properties of elements were studied by means of atomic mass only. So at that particular era, that particular century, atomic mass was considered as fundamental feature of the element. Fundamental feature, मूलभूत मानलं जायचं. Means all the properties of elements were related to atomic mass. And now we are correlating it with what? Atomic number in 20th century, and now we are in 21st century. So we'll discuss in that way only. So attempt made to classify element in 19th century and in 20th century. Okay, so let's begin. Now at first look at here. In year 1817, by this year total number of elements known to us were 33 elements. And one scientist, John Dobereiner, this was the scientist who classified element at first. What he did, he also suggested that the properties of elements should be related to what? Their atomic masses. It should be related to their atomic masses. Just I have told you that at that time atomic mass was considered as fundamental feature of the element. मग त्याने तेच सांगितलं की atomic massशी property related करा. What he did, he made group of, look at here, 3 chemically similar elements, group of 3 chemically similar elements, and to that group he called them as what? Triads. Group of 3 chemically similar elements and he called them as what? Triads. What are the triads? First we'll have the group of that elements made by him. Look at here. We'll have the chart here. And the first triad made by Dobereiner was of lithium, sodium and potassium. I am just writing symbol of the element. Okay. Lithium having atomic mass 6.9, sodium having atomic mass 23 and potassium is having atomic mass what? 39.1. Again we will take the second one, calcium, strontium and barium. Atomic mass of calcium is 40.1, that of strontium is 87.6 and that of barium is 137.3. Third one, chlorine, bromine and iodine. Atomic mass of chlorine is 35.5, that of bromine is 79.9 and that of iodine is 126.9. Okay. These are the triads made by the scientist Dobereiner. What he did, he here arranged the elements in the triad in particular pattern. त्याने ते विशिष्ट पॅटर्नने अरेंज केले आणि तो पॅटर्न काय बघा, ही अरेंज देम विथ द इंक्रीजिंग ऑर्डर ऑफ देअर अटॅक मासेस. increasing order of their attack masses. Look at here, all of these they are arranged with the increasing order of their attack masses. असं का केलं? कारण ते करताना त्याने अभ्यास केला आणि त्याच्या लक्षात आलं देर इज सर्टन रिलेशन बिटवीन अटॅक मासेस ऑफ द एलिमेंट्स इन द ट्रायड. व्हॉट इज द रिलेशन? बघा काय करायचं आपल्याला. हिअर विल कॅल्क्युलेट मीन मास ऑफ फर्स्ट अँड थर्ड एलिमेंट इन द ट्रायड, मीन्स ॲव्हरेज. लुक ॲट इट, विल कॅल्क्युलेट 6.9 plus 39.1 divided by 2, and this will be what, 46 upon 2, and this is 23. And what we can say from this mean or average? We can say that it is equal to what? It is equal to atomic mass of the sodium, that is middle element, second one. Let's do same for these two also. Calcium and barium's atomic mean will take 40.1 plus 137.3 divided by 2. So, it is what? 177.4, and so how much it is? This will be equal to what? 88.7. And so, what we can say now? It is not exactly equal to that of strontium. It is approximately equal to what? Atomic mass of middle one, that is strontium. Let's calculate the same for the third also. 35.5 plus 126.9 divided by 2, and this will be what? 162.4 divided by 2, and this is what? 81.2. And so, what is here? Atomic mass of the bromine middle is what? Bromine is what? 79.9, and so again we can see that it is approximately equal to what? Atomic mass of bromine. This is he observed, and accord means what you can say that the average or mean of the atomic masses of first and third element in the triad will be equal to atomic mass of the middle element, or approximately equal to what? Atomic mass of the middle element in the triad. And this gives rise to a law which is called as Dobereiner's law of triad. It is not given like that in our textbook, but like this is given. Look at here, when the elements in the triad, look at here, are arranged in the increasing order of their atomic masses, What we can say that the atomic mass of the middle element is approximately equal to the mean of the atomic masses of other two elements in that particular triad. This is called as law of triad. याला लॉ ऑफ ट्रायड असं म्हटलं गेलं. मग काय झालं पुढे? सक्सेस झालं? नो. There were certain limitations in this triad or in this classification. What? All the elements known at that time could not classified into triad. सगळेच एलिमेंट्सचा असा 3-3चा गट तयार करता आला नाही. That time Dobereiner made only 5 triads only. आणि काही ट्रायड्सने तर त्याचा नियम पाळला पण नाही. उदाहरणार्थ आपण बघा इथे एक ट्रायड घेतलं आहे कॅल्शियम, स्ट्रॉन्शियम, बेरियम. पण जर आपण दुसरं ट्रायड घेतलं मॅग्नेशियम, कॅल्शियम, स्ट्रॉन्शियमचं, मॅग्नेशियम, कॅल्शियम अँड स्ट्रॉन्शियम, तर यांचा ॲटॉमिक मास आपण घेऊन बघा 24.3, 40.1 अँड स्ट्रॉन्शियम इज 87.6. If you calculate their atomic mass, you will not get approximately equal to. Or another one is there, copper, silver and gold. Atomic mass of copper is copper Cu, 63.5. Atomic mass of silver is 108 and atomic mass of gold is 197. Not yet. And so the classification of this triad was means elements in triad was unsuccessful. Or then next attempt made by English chemist John Newland. He also correlated atomic mass of the element with the properties, but rather different way. By this time in year 1865, number of elements known to us were 63. या काळापर्यंत 63 एलिमेंट माहिती झालेले होते. अँड जॉन न्यूलँड correlated atomic mass and properties with each other, but in different way. What he did? Look at it. In 1866, Newland arranged the elements known at that time with increasing order of their atomic masses, and that elements known as what? From hydrogen to thorium. त्याने एलिमेंट्स इंक्रीजिंग ऑर्डर ऑफ ॲटॉमिक मासेस रचायला सुरुवात केली. मग 63 सरळ लिहिले का? ऑल 63 एलिमेंट्स आर इन सेम लाईन? नो. ही गो ऑन अरेंजिंग द एलिमेंट विथ द इंक्रीजिंग ऑर्डर ऑफ द ॲटॉमिक मासेस, अँड वेन ही केम अक्रॉस द एलिमेंट with having similar property to earlier elements, he put that element below the first one. As for example, look at here. Here elements are arranged. This is a tabular form of elements arranged by Newland in his law of octaves. We can say that. Look what he can look at here. First element is hydrogen, lithium, beryllium. In this way elements are arranged with the increasing order of their atomic masses. And here after oxygen, here next element is should fluorine. But this fluorine was having property that of what? Hydrogen. So he kept fluorine below hydrogen in this way and make like this tabular form of the element and arrange known elements at that time. And he gave a law. त्याने एक लॉ तयार केला. काय लॉ तयार केला? की ज्याप्रमाणे नोट्स ऑफ म्युझिक असतात बघा, सा रे ग म प द नि सा, आपल्याकडे वी कॉल इट एज सा रे ग म प द नि सा, अँड तिकडे डो रे मी फा सो ला टी असं म्हटलेलं आहे. सो ॲज द म्युझिकल नोड आफ्टर 7th नोड 8th node is the first one. In the similar way, when the elements are arranged with the increasing order of their atomic masses, every 8th element will have similar chemical property to that of the first. This is called as Newland's law of octaves. काय सांगितलं? जेव्हा एलिमेंट्स ॲटॉमिक मासेसच्या चढत्या क्रमाने लिहिले तर 8व्या एलिमेंटचे आणि पहिल्याच्या प्रॉपर्टी काय असतील? सारख्या असतील. मीन्स लुक एट हिअर, फ्रॉम हायड्रोजन इन दिस टेबल, हायड्रोजन इफ विल कन्सिडर फर्स्ट, देन दिस लिथियम इज सेकंड, थर्ड, फोर्थ, दिस नंबर नॉट मास, फिफ्थ, सिक्स, 7, and then from hydrogen, which is the 8th element, fluorine. So hydrogen and fluorine will have similar chemical property. From lithium will take 8 element, then if lithium we have to consider as 1, 2, 3, 4, 5, 6, 7, and from lithium 8 element was sodium. So lithium and sodium will have similar chemical properties. Okay, in that way, and this is called as law of triad. Look at it. What is the law of triad then? On comparing with the octaves in the music, Newlands gives law of octaves to classify the element. And look, when the elements are arranged in the increasing order of their atomic masses, every 8th element had similar chemical property to the first. This is called as law of octaves. And he made like this 7/8 tabular form त्याने केला आणि त्याने अशा प्रकारे तेव्हा एलिमेंट अरेंज केले. What problem faced by Newlands? That we also have to discuss and look at here. अशा प्रकारचं क्लासिफिकेशन केल्यानंतर काय प्रॉब्लेम आला? फर्स्ट प्रॉब्लेम, दिस क्लासिफिकेशन मीन्स लॉ ऑफ octaves is applicable only up to calcium. Means after calcium, the elements which are there, they are not possessing or they are not having property of the first element. As for you, look at here. Once again here the table. हा जर आपण टॅब्युलर फॉर्म घेतला तर हा लॉ फक्त कॅल्शियमपर्यंतच ॲप्लिकेबल आहे, एवढ्याच पोर्शनसाठी आहे. आफ्टर कॅल्शियम एव्हरी 8 एलिमेंट नॉट हॅव्हिंग द प्रॉपर्टी ऑफ द फर्स्ट वन. मीन्स बघा ॲल्युमशी कोण आहे, क्रोमियम आहे, नाही प्रॉपर्टीसारखे आहे. किंवा हा सगळ्यात सोपा आहे तुम्हाला बघा. लुक ॲट हियर, सल्फर अँड आयर्न, S and Fe. Now sulfur is non-metal and iron is what? Metal. Obviously no similarity in the properties. So this law was applicable only up to calcium. What again problem there? Newlands placed 2 elements in some boxes according all known elements. काही ठिकाणी त्याने काय केलं बघा, आता त्याने 7/8 चा टेबल केला होता. 7/8 चा टेबल म्हणजे याच्यात 56 एलिमेंट बसू शकतात आणि एलिमेंट 63 होते. मग त्याने काय केलं, काही ठिकाणी 2-2 एलिमेंट एका बॉक्समध्ये ठेवले बघा. 2 एलिमेंट्स इन सेम बॉक्स अँड देअर प्रॉपर्टी वे नॉट सिमिलर, किंवा इतके काही मॅच करत नव्हत्या. दिस ही प्लेस, लुक एट हियर, ही प्लेस सम एलिमेंट्स विथ डिफरंट प्रॉपर्टीज अंडर द सेम नोट ऑफ द ऑक्टेव्स. वेगवेगळ्या प्रॉपर्टीचे एलिमेंट्स एकाच नोटमध्ये म्हणजे एकाच त्या उभ्या कॉलममध्ये ठेवले. लुक एट हियर, जस्ट नाव आय हॅव टोल्ड दॅट sulfur and iron not having similar property, they are placed in this note of the this node. Here same also, look at here in La Adha node, here phosphorus and manganese are there. Phosphorus is non-metal and manganese is metal. So this problem has arisen. Newlands octave did not have provision to accommodate newly discovered element. As this table size was fixed 7/8, where the new elements will be kept? नवीन एलिमेंट ठेवणार कुठे? दिस वॉज प्रॉब्लेम. अँड द प्रॉपर्टीज ऑफ न्यू एलिमेंट डिस्कवर्ड लॅटर डिड नॉट फिट द न्यूलँड्स लॉ ऑफ ऑक्टेव्स. आणि नंतरचे सापडलेले जे एलिमेंट्स होते ते लॉ ऑफ ऑक्टेव्ह ओबे करतच नव्हते. अँड सो द classification in that way was limited, and then again elements need to be classified in rather different way was there, and that work done by a Russian scientist Dmitry Ivanovich Mendeleev, that we have to discuss, that we'll discuss in next lecture. Till then, bye bye, take care.